The second video on thermochemistry is going to combine heat, internal energy along with work, and it's also going to define what a state and a path function are. The next term you are going to learn is a state function. It's a property whose value does not depend on the path taken to reach that specific value. So what are the examples of state function? They are mass, pressure, volume, temperature, altitude, energy, enthalpy, entropy, and free energy. So if you know what a state function is, you should learn also about the next kind of a function. That's a path function. So what is a path function? So in case of a path function, its properties depends on the path you take. Some example of a path function is work and then heat. So let's just understand this now. Consider an altitude, a distance you have to travel between A and B. Let approximately the distance between the two ends A and B is x centimeter. One way you can travel is the way the red line shows, just go straight. Or another way you travel is the way the blue line shows, the longer path. So, but whichever way you travel, the distance between A and B is going to be the same, that is x centimeter. So this altitude or this distance between the two end points A and B is called as the state function. That doesn't change, but the red line and the blue line, the red one will do lesser work to reach the point A from B. However, if you take the path the blue line takes, you are going to do more work. Or in other words, though the distance between the 2 points remain the same, the path which you take, whether you take the red path or the blue path, depends on the path you take determines how much of work you are going to do. Or in other words, work is something which is called as a path function because it's not defined by the two. Your aim is to reach A, but I can go any way I like. So the amount of work you do using the red line or the blue line is different, and hence work is a path function and all the others given over there is a state function. So it's not such a big thing. Remember the state functions given over there and remember that work is a path function. That should be enough to understand at this point. You will be learning about it later again in thermodynamics. Some of the things you have to learn about work, heat, and internal energy. These three are connected by the equation delta U equals Q plus W, where U is the internal energy, Q is the heat, and W is the work done. And the formula for work done is equal to minus P delta V. And P is the pressure, delta V is the change in volume. And you notice that there is a negative sign over there in front of W. And units for energy, heat, and work in this equation is joules. And if you are using calories, all of them should have a unit of calories, but in general we work with the unit of joules. So another thing, actually what you have to understand in this chapter is the sign of Q and W. That's very important. So spend a few seconds and understand what's given in these two tables. Make a copy of it and keep it next to you whenever you're doing a question on work, heat, and internal energy. For example, the first table explains that if the process is exothermic, because sometimes it will not be given to you, you have to decide based on the sign given there. If the process is exothermic, heat should be taken as negative. Process is endothermic, heat should be taken as positive. And if the question says heat is released, you have to put the sign negative in front of heat. And if it says absorbed, you should put a sign of positive. And as far as the work done is done, if it says work is done on the system, then work is positive. Work is done by the system, it's negative. And if somebody says there is no change in volume, then the work done is equal to 0. And if says expands, volume increases, then delta V is positive, and if they say compression and volume decreases, delta V is negative. So take a few seconds, understand all these things before you go further. Calculate the change in internal energy in joules for a system that absorbs 168 joules of heat and does 135 joule work on the surrounding. So the equation you are going to use is delta U equals Q plus W. Now from the question you see that it says heat is absorbed, then Q is positive. Then it also says work is done by the system, hence W is negative. So this is very important as far as the sign is concerned. Then substitute it into the equation. Delta U equals, I take the positive Q, 168 joules, and in front of W I put a negative because it says work is done by the system, and hence it is negative 135, and the value comes as 33 joules. Calculate the change in internal energy in joules for a system that releases 325 joules of heat and a work of 285 joules is done on the system. These words are important. So use the same equation, delta U equals Q plus W. They say heat is released and hence Q will be negative. And then it says that we do work is done on the system, then W will be positive. So substitute, take the value of Q as negative and take the value of W as positive and put it in the equation, and I get the value of internal energy as negative 43 joules. So these questions are pretty simple, but only thing you have to take care is the sign of Q and W. Calculate the work done in joules when a system is compressed from a volume of 25 liters to 18 liters under a constant pressure of 0.520 atmosphere. The equation for work done and P and volume is W equals negative P delta V. And what do you mean by delta V? Delta V is a change in volume, and that's equal to final volume minus initial volume. So substitute the values here, and pressure is 0.520. There is a negative sign because the equation itself has a negative sign, and the volume changes from 25 to 18. So the final volume is written first, then the initial volume. So the change in volume is negative, and hence the work done will be positive. And the unit of work done, it comes as atmosphere and liter, or liter atmosphere. They have asked you to report the answer in joules. So the conversion factor is 1 liter atmosphere is equal to 101.325 joules. Use that and convert the work done into joules. And you can see that since the value of W is positive, work is done on the system. Calculate the work done in joules when a system expands from a volume of 125 to 225 under a constant pressure of 1.47 atmosphere. Use the same formula, W equals negative P delta V, and P is given, and we know that delta V is final volume minus initial volume. Substitute all the values, and in this case the value of delta V is positive, hence I get work done as negative. And here also, since I get in atmospheric liter, convert the liter atmosphere to joules using the conversion factor, and when I calculate the work I get negative 14.9 kg and kJ. And since W is negative, work is done by the system. So expansion, work is always done by the system. Compression, work is always done on the system. Calculate the change in internal energy in joules for a system that releases 328.0 joules of heat and undergoes an expansion in volume of 25.5 liters against a pressure of 855 torr. We are going to use, since it is change in internal energy, we are going to use the formula delta U equals Q plus W. Before going into the question, let's just write down the facts which we already learned or revise on them. it says heat is released, and hence Q should be negative. And it says expansion of volume. Whenever expansion happens, delta V is positive. Yes, and you can see that, so you have to just take a positive value. And then expansion of volume means work is done by the system, and W is negative. This is just revising on whatever we have learned earlier. Now use the formula. Before we substitute it into the formula of delta U equals Q plus W, let's calculate W first. So using the formula W equals negative P delta V, we can calculate the work done. So in this case, if you see that the pressure given over there is in torr, you have to use the unit of atmosphere for pressure. So the volume should always be in liters and pressure should be in atmosphere. So convert the pressure into atmosphere and multiply it with the volume and get the value of work done in liter atmosphere, and as expected it comes negative. Then convert that into joules using the conversion factor. 1 liter atmosphere equals 101.325 joules. So I have the work done and the heat is given. Substitute it into the formula delta U equals Q plus W. Notice there is a negative sign in front of Q, and calculate the total internal energy. So it will be just 328 plus 2946. So all these questions, the questions are simple. You should be careful about the sign you use. Calculate the final volume when a system with an internal energy of 5472 joules compresses from a volume of 26 liters against an external pressure of 2.50 atmosphere, and it absorbs a heat of 1183 joules. So the question is similar. Use the same equation, delta U equals Q plus W. In this case, delta U is given and Q is given. Q, because it is it absorbs heat, therefore it is positive. And so first let's calculate the work done using the formula delta U equals Q plus W, and I get the value of W as 4289, and it's a positive value. And since it is compression, it comes in accordance with what we expect. W is positive, and this is the unit of joules. And since the pressure is given in atmosphere, convert the work done into liter atmosphere, and then you know the conversion. 1 liter atmosphere equals 100. If you forget it, just go before and see it. And once you get the work done in liter atmosphere, use the formula W equals negative P delta V and substitute the values in it, and I get the final volume as 9.87 liters. In doing such questions, you will never get pressure or volume as negative. So if you are getting it, it means that you have not used the appropriate sign. The only thing which can be negative is delta U, Q or W. P and delta V or the individual volumes can never be negative.